Stateful widget. In Flutter, a stateful widget is a fundamental building block for creating dynamic and interactive user interfaces. Unlike stateless widgets, which are immutable and do not change once built, stateful widgets maintain a mutable state that can evolve over time. This is crucial for applications that need to respond to user input, such as tapping buttons, entering text, or loading data from an API. When you create a stateful widget, you define two classes, the stateful widget itself and the associated state class. The stateful widget serves as a container for the state, while the state class contains the logic and variables that can change during the widget's life cycle. One of the primary advantages of using stateful widgets is their ability to rebuild the UI in response to state changes. This is achieved through the setState method, which notifies the Flutter framework that the internal state of the widget has changed and that the widget should be rebuilt with the updated data. This mechanism is essential for creating a responsive user experience. For example, when a user taps a button, you can call setState to update a counter, and the widget will automatically redraw itself to reflect the new value. This approach allows for seamless interactivity, making the application feel more dynamic and engaging. Stateful widgets also support various lifecycle methods that provide hooks for managing the widget's state throughout its life cycle. The most commonly used methods are initState, didChange dependencies, build, and dispose. The initState method is called once when the widget is first created and is the perfect place for initializing variables or performing setup tasks. For instance, if your widget needs to fetch data from a server, you might initiate that request in initState. This ensures that the data fetching starts as soon as the widget is created, making the app feel more responsive. The didChange dependencies method is called immediately after initState, and whenever the dependencies of the widget change, such as when an inherited widget is updated. This method is useful for scenarios where the widget needs to respond to changes in data that it depends on, such as themes or localization. By overriding this method, developers can ensure that their widget remains in sync with changes in the app's context. The build method is where the widget's UI is constructed. It returns a widget tree that describes how the UI should look based on the current state. The build method is called every time setState is invoked, allowing the widget to reflect the latest state changes. It's important to keep the build method efficient since it can be called frequently during the widget's life cycle. Lastly, the dispose method is called when the widget is removed from the widget tree. This is the appropriate place to clean up any resources, such as canceling timers, closing streams, or disposing of controllers. Failing to do so can lead to memory leaks and negatively impact the performance of the application. Stateful widgets can be used in a variety of scenarios, such as creating forms, managing user interactions, and displaying dynamic content. For example, consider a simple login form that requires the user to enter their username and password. A stateful widget can be employed to manage the input fields, display error messages, and handle form submission. As the user types, the state of the widget can be updated to reflect the current input values, and upon submission, the widget can validate the input and display success or error messages accordingly. In summary, stateful widgets are a powerful feature of Flutter that enables developers to build interactive applications with dynamic content. By managing mutable state and leveraging lifecycle methods, stateful widgets allow for responsive and engaging user experiences. Understanding how to effectively use stateful widgets is essential for any Flutter developer, as they form the backbone of many applications, providing the flexibility and interactivity that modern mobile users expect. initState. The initState method is an integral part of the stateful widget lifecycle in Flutter, serving as a crucial point for initialization when a widget is created. This method is called once and only once, when the state object is created. As such, it is an excellent place for performing any setup tasks that need to occur before the widget is built for the first time. This includes initializing state variables, fetching data from APIs, and setting up listeners or controllers. One of the primary use cases for init_state is to fetch data asynchronously from a remote server. For instance, when building a weather application, you might want to retrieve the current weather data as soon as the widget is created. By placing your API call inside init_state, you ensure that the data fetching process begins immediately. This can enhance the user experience by making the application feel faster and more responsive. For example, you might use the HTTP package to send a request to a weather API and then update the state with the received data, triggering a rebuild of the UI to display the current weather conditions. In addition to data fetching, init_state is also useful for initializing any variables that need to be set up before the widget is displayed. For example, if your widget requires a timer or an animation controller, you would instantiate and configure those objects within init_state. This ensures that they are ready to be used when the widget builds for the first time. Moreover, because init_state is only called once, it is a safe place to set up resources that don't need to be recreated every time the widget rebuilds. However, developers need to be mindful of what operations they perform in init_state. Since this method does not have access to the build context of the widget, it's not suitable for operations that rely on the context, such as accessing inherited widgets or using media query. For these scenarios, the did_change dependencies method should be used instead. This method is called immediately after init_state, and is the right place to handle context-dependent operations. It allows developers to update their widget in response to changes in dependencies. Another important consideration when using init_state is error handling, especially when dealing with asynchronous operations like API calls. If an API request fails or returns an error, it's crucial to have a plan for how to handle that situation gracefully. You might set up a variable to track the loading state and update the UI accordingly, displaying a loading indicator while waiting for the data to arrive. Once the data is fetched, you can use setState to update the UI with the new information or show an error message if the request failed. The life cycle of a stateful widget involves more than just init_state. After the widget is created and initialized, it enters the build phase, where the build method is called to render the UI based on the current state. It's essential to understand that the build method can be called multiple times throughout the widget's life cycle, especially when setState is invoked. Therefore, it's crucial to keep the logic in build efficient to avoid performance issues. Finally, when the stateful widget is removed from the widget tree, the dispose method is called. This is the appropriate place to clean up resources, such as canceling any ongoing API requests, disposing of controllers, and removing listeners. Failing to do this can lead to memory leaks, which can degrade the performance of the application over time. In summary, init_state is a vital part of the stateful widget lifecycle in Flutter, providing a place for initialization tasks that need to occur when the widget is first created. By understanding how and when to use init_state, developers can ensure that their widgets are set up correctly and efficiently, enhancing the overall performance and user experience of their Flutter applications. Get data from Weather API. Fetching data from a Weather API is a common functionality in many mobile applications, allowing users to access real-time weather information. In Flutter, the process of retrieving data from an API typically involves using the HTTP package, which simplifies making network requests. To start, you'll need to add the HTTP package to your pubspec.yaml file, enabling your application to make HTTP calls. After setting up the package, you can define a function that constructs the API request. For example, let's consider using a popular weather API like OpenWeatherMap. The API requires certain parameters, such as the city name, country code, and your unique API key, which you receive upon signing up for their service. The endpoint for fetching weather data typically looks something like this: https://api.openweathermap.org/data/2.5/weather, q equals city, country, and a PID equals API_key. In your Flutter application, you can create a function that constructs this URL and makes an HTTP GET request to retrieve the weather data. When making the request, it's essential to handle the response properly. The HTTP package provides a simple way to make asynchronous calls using the future class and async/await syntax. By awaiting the response, you can retrieve the data without blocking the main thread, keeping your application responsive. Once you have the response, you'll typically check the status code to ensure the request was successful, status code 200. If successful, the response body will contain the data in JSON format. Parsing the JSON data is the next step. Flutter provides the Dart convert library, which includes functions for encoding and decoding JSON. You can use the JSON decode function to convert the JSON string into a Dart object. Once the data is parsed, you can extract relevant information, such as temperature, humidity, and weather conditions.
The end.